across our VIS delivery, right? And so Trent, what are we looking for here? What are we trying to screen for?
Just a second.
Why is this cross tabulation important?
People in each cell?
The number of people in each cell. And what do we want to avoid?
Cells less than 5?
Yeah, we want to make sure that we've got adequate coverage in my cells, right? I don't want to be having some cell in this matrix trying to predict something where there's not adequate representation here. And so again, what we want is we want no expected value less than 1, right? And so if we go through and we take a look at our expected counts, those are all looking good. Nothing less than 1. We've got a reasonably large sample, and it looks like this has been sampled pretty well in terms of these different modalities of delivering the VIS. Also, don't want less than 20. We want less than 20% of the cells with expected values less than 5. Expected values less than, or excuse me. We want a small proportion of our cells having expected values less than 5, right? You can have some, you just don't want more than a fifth of those values being less than 5. And if we go through and take a look here, they're actually all above 5, right? So we're doing pretty good here. Dude, what are you looking for?
I thought I can't find that one. I was wrong. I have 2 of the same one.
Oh. There you go.
Thank you.
No problem.
See why I'm so confused, sorry.
Yeah, no worries. Okay. So we've gone through taking a look at our distributions. Again, we don't have any distribution assumptions, but it's just nice if our models work out a little more efficiently if we do have nice clean data, but if we don't, that's fine. That's why we go through and we use these logistic models as one of the benefits. We do want to make sure we don't have crazy outliers that are going to screw around things, right? So we want to do something with that. We want to go through and check our cross-tabulation to make sure we've got reasonable representation across our categorical variables, and it looks like we're doing okay with that respect. And then what we're going to do now is we want to go through and test the linearity of our login. And so what we're going to do we're going to compute the natural log of impact. What we're going to do here is we're going to go ln times 1 plus y1 plus number of VIS.
Can't have zero or negative.
Exactly. So we have 0. We have some people who don't have a number. They have no VIS statements, right? And so we need to make sure that we take care of that. We also want to go through and do the same thing for our depravity score. And again, depravity 1 plus our depravity score. Okay. We go through, calculate the natural log of our continuous predictors. Okay. So now what we're going to do, so we're going to go to analyze. And we're going to go down to regression. We're going to select binary logistic. outcome is going to be our sentence, right? And here what we're going to do is we're going to have our centered impact, our centered depravity, natural log of our depravity and our impact, right? Okay. Now what we're going to do, and this is where your logistic models will do you some favors, because what we can do is we can go impact, there we go. So if you go through and you click on impact, centered impact, and then you hit control, and you click on the natural log of impact, okay? So you've highlighted those two, and then you've got this A times B, and that will just drop that in there, right? Same thing with depravity, control, hold down control, natural log of depravity, throw that interaction in there, okay? And then we've got VIS delivery that we'll drop in there, okay? So what we've got is we've got a model that has our two continuous predictors. It's got the natural log of our two continuous predictors, and it's got the interaction of the actual predictor and then the natural log, and then it's got our categorical variable in there too. And what we're looking at, what are we looking for, Stephanie? What are we hoping doesn't happen?
I don't know. I'm not quite sure.
Anybody? What are we hoping doesn't happen here?
The interactions are significant. We're hoping they're not significant.
Right. We're hoping that we don't have evidence of that we don't have a violation of the linearity of our logit, right? So we go through and we run this, and we're going to get a lot of stuff, but really what we're going to want to go down through and take a look at is our variables in the equation, our very last table here. And we've got a couple extra things in there. It looks like I actually lied to you and didn't actually put VIS.
Yeah.
That was the linear, it's the log, natural logs.
It's just a regular.
Oh, right. Okay.
Don't we need to define
There we go.
the reference group for BIS? Or no?
Yep, scratch that. Let's go back to, so we've got our, taking our natural logs out of there. Okay, so we've got centered impact, centered depravity, the natural log of impact and the natural log of impact and impact, and the natural log of depravity, and then VIS delivery. Which we should actually, just so that we have a proper model here. Go to regression, binary logistic, and probably what we ought to do is go to, click on this categorical up here, and tell it that VIS delivery is a categorical variable. And it doesn't matter which indicator or how we're going to be doing that. And then go through and paste. So what we've done here is we've told SPSS that our VIS delivery is a categorical variable. It's not a continuous variable. Before it would just, if it went through just 0 to 4, it would treat it as a continuous variable, which actually isn't a thing. Just to do this properly, making sure that it knows that VIS is a categorical variable, and then take it from there.
And it doesn't matter which one we have as our reference group.
No, right?
And why not?
Because we're not interested in that as predictors, we're just interested in whether or not these interactions are significant. So
Okay.
we will get there when we actually run our model.
Okay, gotcha.
Yeah. So this is
Gotcha.
this
Okay.
is just our screening, right?
Okay.
And so we go through, Does someone have a pen I can borrow? Never mind, I got one. Make a note on this thing, so. So you can see in your handout, we've got an issue where what I've done, at least when I put together this thing, is I didn't indicate VIS delivery as a categorical variable. Treating that as continuous, which doesn't make any sense, right?
Yeah.
So that should be indicated as a categorical variable, which is why I went back up through and changed that. I'll make a note to change this outcome. But what we're interested in here is whether or not we have evidence of significant interaction effects, right? So again, if we go through and we take a look at our interaction of impact by a natural log of impact, that's clearly not significant. Natural log of depravity and our depravity scores, that's not statistically reliable. So everything else we're not too concerned about. This is just wanting to make sure that we don't have nonlinearity in our logit, right? Because our logit is a continuous outcome. What we want is all of our continuous predictors to have a linear relation with our natural log or our log odds. Here it looks like we don't have any problems with that. Okay? Yeah.
Do we want our natural log of impact and natural log of depravity in there, not as interaction?
It didn't, yeah, it didn't delete it from when you deleted it.
Oh,
It ran it with everything again.
you ran it with everything again. We'll get it right one of these times. Okay.
And that's fine.
It is.
Probably. No, that's perfect.
You're all night now.
I just can't for myself.
Yeah, no. Just use.
You don't wanna review it,
like
point it out.
honestly, like as being up here, I get incredibly excited when you guys sort of note the bonehead stuff that I'm, because it means you're paying attention, you're thinking about it. Not
I just accept it as fact. I'm just like, oh, that doesn't seem, okay, whatever.
No, don't do that. Don't do that, because I sort of screw this stuff up all the time, right? Okay, so if we're going through still not finding evidence of a statistical effect of your interaction terms, so we can say that as you're going through in our screening saying, we do have evidence of linearity in our logit, right? So have gone through and taken a look at most of the stuff that we really probably need to be worried about. But again, when you're going through and doing your own screening, make sure that you're systematically going through testing sort of your basic assumptions of logistic regression, and even making note of those distributional assumptions and things like that that we wouldn't normally worry too much about, right? Again, Tavachik and they'll do a nice job of working through some of those things. Again, this will be a nice chapter for you to go through and take a look at as well. So let's go through, and so we're, at least for this demonstration, we're going to say our assumptions are good enough or not, because we probably should have done something with those extreme values, right? But we're going to pretend we didn't see those. And we're going to go to our logistic model. Okay, now this time we're going to run this for real and true. And so what we want is we've got sentence as our outcome, right? And then we want our centered impact, centered depravity score, and then we want our VIS delivery, right? So we've got our three predictor variables. Now, again, what's nice about these models is we don't need to go through and physically create indicator variables like we would in a normal regression. What we can do is we can just go through and we can tell SPSS that, okay, this is a categorical variable. Right? Do we need to tell dichotomous predictors are categorical? No. I mean, you can if you want to, but it's not necessary. It's just going to, we can model categorical predictors as if they were linear, just like anything else, right? But if you've got a multi-dichotomous predictor with 3 or more levels, what you want to do is click on this categorical variable thing, tell it that VIS delivery is a categorical variable, And then what you can do is you can play around with how you want it to model this, right? Base is an indicator variable, right? So you can go through and what it'll do, it'll go through and it'll choose and provide you a coefficient for sort of all your target criteria versus a reference, just like a normal indicator variable would. But you don't have to do that. If you go down through, you can see these contrasts. There's all sorts of different types of contrasts that you can use, right? And these different contrasts do different things, okay? So like indicator, codes presence or absence of category membership. Simple compares each effective category to the last, right? So here it would be 0 versus 1, 1 versus 2, 2 versus 3, 3 versus 4, which could be something that's useful if that's relevant to your design. Difference compares the effect of each category to the average effect of all the other categories. Helbert compares the effect of each category except the last, the average of the subsequent categories. So there's different types of things that you can set up based on sort of your specific questions, right, that you want to put in the model. But indicator variable is going to be your sort of the basic run-of-the-mill, and it will probably do most of the things that you'll want it to do, unless you want to start comparing. So category 3 versus category 4, right? That's not going to work within this, right? You've got, so this is my baseline. We're comparing all the others to the baseline. We don't really care about comparing things to each other relative to the baseline, but you can go through and start to get more elaborate with these in the model if you'd like, okay? Other thing to remember is down here, reference categories, reference category the last or the first. In this case, I don't know why it usually selects the last category as the reference category always, but in ours coding, 0 being none, I want that to be my reference category, right? So I want to go through and collect that first, and I don't know if I would have reverse coded this where no VIS would be my last, then it would sort of change, right? So this is where it's important to know what your variables are coded, how they're coded, and where things go, okay? So we've got told that VIS delivery is a categorical variable. We're comfortable with it running indicator coefficients here. We want first to be our reference group, and then it's important you go through and you hit change, right? When you hit change, you'll see this changes up here. It says, okay, indicator, parentheses first. Make sure you do that, because if you don't do that, it won't do it, and then hopefully you'll catch it on the back side, okay? You go through, hit continue, and then go through and look at your options. You can save predicted values, you can save probability, group membership, right here, if you're interested in doing that. You got various residuals and influence measures. These are like multivariate outlier types of things that you can go through and test if you wanted to do that, right? We won't worry about it now, but those are things you can do. Options, we want we'll ask for confidence intervals for our coefficients, right? This is a nice thing we want to do. And again, this is nice because our odds ratios, this will begin to give us 95% confidence of intervals around our odds ratios, which should excite the hell out of you, because that means you don't have to do it by hand or create a calculator or some other such nonsense, right? It'll just do it for you. So go ahead and click that. And then there's some different stuff that you can go through and play around with. You're not worried about this right now. So just make sure to click your confidence intervals and then hit continue and then stop, and won't worry about that. Okay? And go through and paste. So here's our logistic model. Go through. I'm actually going to shut all this down. Yeah. Okay. You got a fresh start here. All right. So first thing we want to do, and always, always, always do this because it's going to help you not make mistakes. Make sure that you've done what you want to do in terms of these models. Your first